Hey guys, so today we're actually going to do a problem. It's just going to be pretty basic, and it's going to be drawing on a lot of the stuff that I talked about in the last video. So we're given a problem where the disc rotating, sorry about my poorly drawn disc, I thought I could draw it by freehand, but it didn't really work out. Anyway, so we have a disc rotating, and it's rotating about its center. We're going to pretend this is perfectly circular and this is its center. We're given a radius, which is equal to 0.8 meters, and we're given an angular velocity, which is equal to 5t squared plus 2, so it's in terms of time. There's a point on this disc just called A, and the question asks us to find the velocity of point A and the acceleration at point A. So, the first thing that I'm going to do is I'm going to find the angular acceleration. We have angular velocity. We know that angular acceleration is equal to the derivative of angular velocity. So it's easy enough to find as long as you've taken a calculus course. 10t plus 0, so just 10t. And that's our equation for angular acceleration. Oops. In radians per second. So I'm gonna just sub in for our time now. I guess I forgot to write it, but the time the question gives us is asked to solve at time is equal to 0.5 seconds. So I'm gonna sub in for this time that the question gives us, and it's equal to omega times 0.5 squared plus 2 gives us an omega value of 3.25 radians per second, and you can confirm that by putting that in your calculator. Alpha is the same, we're just going to sub in for our time, so it's 10 times 0.5, and you can probably do that in your head. That's going to give you 5 radians per second squared. So, now we have angular velocity and angular acceleration. But we're not looking for those, right? We're looking for velocity and acceleration of this point A. So, how does this help us? If you remember my last video, I gave you a relationship for if you're rotating about a the center and it's a fixed axis, you can find that your velocity is equal to omega r, where r is the radius. And just subbing this in simply, we can find that our velocity of point A is equal to 3.25, which is our angular acceleration, times the radius, 0.8 meters, and that gives us the value of our velocity, 2.6 meters per second, and you can confirm that again in your calculator. Acceleration is a bit trickier, but I touched on this in the last video too. So acceleration is going to have two components. It's going to have its tangential component and its normal component. So, the tangential component I defined last time as being equal to alpha r. So it's equal to the angular acceleration times your radius. So in this case, it would be equal to 5 times 0.8. And that gives us an acceleration tangential of 4 meters per second. So assuming this is rotating this way, your acceleration tangential is going to look like that. And acceleration normal was a bit weirder, but it was equal to omega squared times r. And so that gives us 3.25 squared times 0.8. And doing the math for that gives us 8.45 meters per second. Oh, and this should be squared, both of these. So now we have a normal and a tangential. So just the normal would look like this because it would be going straight for the center. So if we wanted to define an axis where, say, this was x and this was y, we could define acceleration of A as being equal to as you can see, the normal one would be negative y, so it would be negative 8.45 j hat, and the tangential would be negative x, so it would be negative 4 I hat, and these would all be in meters per second squared. We could also, instead of defining this in terms of coordinates, we could just take the magnitude of it, and that would be sufficient for this problem. So we just have 4 squared plus 8.45 squared square root. You've probably all taken the magnitude before. And that gives us, oh, I didn't calculate this before. One sec, I'll just plug this into my calculator. And this will give us 9.35 meters per second squared. And so that's it. You solved for the velocity at A and the acceleration of A.